All right, here we go. So we have we have sine. We've gone through the derivatives. We have the first four derivatives. Now we have to evaluate these at 0. So what is sine at 0? 0. That's okay. It's been a while. What's cosine at 0? 1. What's sine at 0? 0. What's cosine at 0? Negative cosine at 0.
-1.
-1. And what's sine at 0? 0. Yes, those are values directly from the unit circle. Now, the zeros, what's going to happen with some of those terms? They're going to disappear, but because we're still new at this, I want to write them all out. So we have f of 0, so f of 0 is 0. The first derivative at 0 is 1 times x. The second derivative at 0 is 0, x squared over 2 factorial. What's the next one going to be?
-1.
-1, x to what power? Third over 3 factorial. Then what's next?
0x to the 4th.
Plus 0x to the 4th over 4 factorial. Now, I know we didn't do derivatives, but keep going. What would be next?
1.
1x to the 5th.
Positive or -1? Positive. Oh, no tricking you guys. Okay. And one more, actually I'm out of space. So that's what the pattern would be, right? But this one's a little bit tougher to come up with the end notation. So this is what do I have going on here?
It's the n over n factorial.
X n over n factorial. I disagree. It's a good start. What does not work about this expression? Well, you know what? I should really write down what we really have. I didn't put the zeros. We really have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. What would the next term be? Yep. Then what? There you go. So that's what this super expanded form is going to look like. Once I put the zeros in, it looks like this version. So this doesn't work exactly because my version only has the odd exponents in it. No. And it alternates signs.
That would be a negative.
So you want a -1 to the n? Okay, we need to have that as well. 2n plus 1. That's showing congestions. What do we think? The conversation.
Yeah, that's right.
Which one?
2n plus 1.
Would they both get you an odd number?
Yeah. Oh, so it depends on where it starts. I guess, yeah.
Depends on where it starts. Awesome. I've seen both of these. I think the plus 1 is a little bit more common, but I've seen them both. Now, if we're dealing with 2n plus 1 in the exponent, right? So n to the 0. So now this is n equals 0, n equals 1, n equals 2. So 2 times 0 is 0, 0 plus 1. This is x to the first, good, over 1 factorial. This is to the 0, that makes it positive. Does the alternating piece work out? N equals 0, n equals 1. Okay, so the alternating piece is okay, this is okay. The factorial is not okay. 2n plus 1 factorial. You guys have those red papers with you?
Yeah.
You cheated, yes. Got it. So if you look on your red paper, you will see that this series notation is equal to this polynomial expansion, which is equal to sign. Where do I start and end here? N equals 0. So that's where those other series on that red paper come from. They are, we're assigned the second one down, -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And then where do they converge? For all x, and that's part B for this problem. It says to prove it. I don't want to prove it. We're just going to read it off the red sheet and know that it converges for all x. All right, so how is it coming up with a Maclaurin expansion? It's good. Example 4, same idea, but now we're not dealing with sine. What are we dealing with? Cosine, give it a try. You do it.
Is that what's gonna be the first four derivatives?
And that's just what I chose. It could be 4, it could be 5, enough to give yourself a pattern. It was not really enough to do that. Okay, so what do we have? You have x to the 2n?
Plus two.
What else?
Plus 2. There's no 3.
Are we timesing by 2? Yes.
2n.
So this is n equals 0, this is n equals 1, this is n equals 2, this is n equals 3. So x to the 2n, what about over the factorial?
1 factorial.
2n factorial, I am missing the alternating piece.
-1 to the n.
Does that work?
Yes.
Yeah.
0 to the 1, so this is -1 to the n, and where do we start?
0.
0, and where do we end? That's where cosine comes from. I kind of like these. I like the pattern that goes with them. So example 5, this time we want a Maclaurin expansion for sine of 2x. What's going to get a little wonky on this one? The 2 with the derivative, right? So because there's a 2x in there, what do we have to worry about every time we take the derivative? Chain rule. It will always be multiplied by 2. So you guys work on it and I'll work on it as well. Earlier, Angel asked, hey, do we need 4 derivatives? You need enough to find a pattern, whatever that number is for you.
Well, I was waiting for like, figuring out if it was-
How'd you start from the beginning? Because, you know, practice. I'll show you another way that you could have done this. So if this is the expansion, what would this look like as the series notation? Do that one more time for me. 2x. And then what's on the bottom? I like it. So for example 5, this is the process of writing them all out. This is what you get. What else could we have done maybe? This stuff is so weird. No ideas from it. Yeah, there you go, Joey. That's what we say. Thank you for articulating that for me. That sign? No. See, I don't have 2n plus 1. Oh, great. So what Joey's saying way better than I am right now is we could have taken this x and replaced it with 2x because that's what's different. So sine of 2x would be that same series, -1 to n, 2x to the n plus 1, all over 2n plus 1. You have it memorized, hey, that works well. But if you don't have it memorized, can you always go back to the beginning? Yes, yes, you can. All right. Oh, this is fun. So fun. So fun.
Oh, yeah.
So fun.
Like it looks bad, but I feel like it won't be.
Where would you? Propose it on the board?
You think it looks bad, but what, Ashton? What was the rest of it?
I think it won't.
Yeah,
You think wrong.
well. How do you feel about foiling?
Oh, I forgot about. Yeah, never mind, I'm wrong.
Let me switch it here.
So my question for us is, what's e to the x? What were the first couple terms of that?
You did that.
ADX, ADX.
No,
1, 1.
what was the series expansion? 1 plus,
1 plus 1 plus 1 plus 1.
x
X plus one x squared over two.
over two plus
X to the third over three. Factorial.
3 factorial, 2 factorial just happens to, plus what? And x to the 5th over 5 factorial?
Yeah.
And dot, 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 that goes forever. What about cosine? You just said that one.
Me even forgetting. One minus x squared over two factorial plus x to the fourth. Four factorial minus x to the sixth.
And it keeps going, yes. So what did the directions ask for in example 5? The first 5 terms. So I have the terms for E, I have the terms for cosine, so how do you suppose we come up with the terms for E of x times cosine of x?
Multiply them.
Yay! So we replace the E to the x with all this funness. And we replace cosine of x with all of that funness. See, Ashton, I'm really excited. Because what am I about to ask you to do?
Oh.
No, Angel's figured it out. Well, what am I going to ask you to do? You have to fill it out. Now, how many terms do we need?
5.
We need the first 5 terms. So you start with the constant, then your x to the first, x to the second, x to the fourth, x to the fifth. Whatever does or does not occur in there. Are we going to wind up needing x to the 8th? Probably not. So you could go crazy and take 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5 and come up with 30 terms. But we don't really need 30 terms. So you do want to be smart about it. I am going to I'm going to multiply these higher exponents by each of these. So I'm going to take 1 and distribute it through. So I have 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4 factorial plus x to the fifth over 5 factorial. Okay, I've distributed 1. What else do I have to distribute? X squared over 2. What do I do with that? Distribute it through, and not just x squared over 2, but what's hiding in the front. Don't forget the negative sign.
You don't need the x.
Probably not.
So you just do the constant of this x to the first, second, third, fifth.
So I just put it on my list because it's good to talk about. Ashton just asked, do we really need the x to the 5th factorial for this one? I think is that what you were asking?
We don't.
Because it gets us up to the 6th and 7th. Here's what you have to be careful about. If I ask for the first 5 terms, it doesn't necessarily mean that I go to a power of 5. Because we can have some terms cancel out and become 0. So we might have to go an additional power beyond that term. Sometimes they will ask for a degree. Sometimes they will ask for a number of terms. All right, I'm thinking x to the 4th might get us to where we need to be. So plus x to the 4th over 4 factorial plus x to the 5th over 4 factorial plus x to the 6th over 2 7. And if I multiply by x to the sixth, the lowest power I'm gonna wind up with is an x to the sixth. I don't think we're gonna need that. Do you get the idea? Yes. You can do this with any two series on that list, the expanded forms of them, you can multiply them out. What are the chances of you seeing one like this? Fairly small, but it is possible. All right, so now that we have this whole list of terms, what do you suppose is next? What would an algebra 1 teacher call it? We're gonna combine like terms.
Oh,
What do you think my pre-algebra students would say right now if they walked into the room? They would panic.
Mother of God.
Yeah, they would have a heart attack right here. So we want to combine like terms. So f of x, start with your constant. I know in algebra we start with the highest power and work our way down, but what's the highest power that we're dealing with?
7.
What's beyond the dots?
B.
Beyond the 8. Infinity. So we're not going to start at infinity. We don't start at the highest power. We're going to start at the constant. So here's a 1. Got it. What would be next? Just x. And I don't think we have any other just x's. All right, cool. 2 terms down. What's next? X squared. So I see an x squared here, but I see negative x squared over 2 factorial there. So what's going to happen with those two particular terms? They cancel.
No.
So that's a big old 0. So what's after x squared? X cubed. We have 2 x cubes. Really? X cubed over what? Let's do this. I have x cubed over 6, and I have minus x cubed over 2. Because I've got this one and this one. So 1/6 minus 1/2. What would that be? Negative what? So this is, and I just wrote the wrong powers there. So both cubed. So negative 1/3 x cubed. All right, so that takes care of the x cubed. So what's next? You're right. X to the 4th. So here's an x to the 4th. Here's an x to the 4th. Here's an x to the 4th. Super fun. Does anything happen to cancel out for us? In fact, yes. No. So I see a positive x to the 4th over 4 factorial minus x to the 4th over 2 factorial 2 factorial plus x to the 4th over 4 factorial. In my head, I multiplied those together and called it 4 factorial, but that's not true, is it? What's 4 factorial? 12. Or, nope, 24. And 2 factorial is really 2, so 2 times 2, yes, makes this 4. So I have 2 24ths minus 1. 2. Negative 1/6. Let me know if you got the same thing. All right, thank you. So we've got constant to the 1st power, squared power canceled out, to the 3rd power, to the 4th power. What would be next? This bit, and I don't think this one cancels out. I hope not. So here's x to the fifth. Here's x to the fifth. Here's x to the fifth. This is -1/30 times x to the fifth. Doable. Annoying. Tedious. If you mess up a negative sign, are you gonna be in trouble? Yeah, but it is doable. It is doable. All right, one more, and that's example 7. If we did the Taylor series expansion for cosine, why did they use the word Taylor this time? So we're doing that pi/2. So we're going to start this from the beginning. We have cosine x. So first. Negative sign. Negative cosine. Cosine. Alright. Now where are we evaluating these derivatives this time? Pi/2. So cosine of pi/2 I know is 0. This one's -1. Yes. Cosine is 0. This is 1. This is 2. So it's the same formula we had before, the same expansion, except we now evaluate it at pi/2. So it's f of pi/2 plus the derivative, first derivative at pi/2. X minus pi/2 to the first over 1 factorial plus the second derivative at pi/2. X minus pi/2 squared over 2 factorial. Dot, dot. See a lot of eyes coming up to the board. Are you okay with the process? I know you're doing a lot of writing. I almost find these easier to do on my own than trying to watch somebody else to do that, because I get lost in the parentheses. While you're still finishing up, do you think of a series notation that would work here? Well, it does go negative positive, so I know I gotta have a -1 something. We know these terms cancel out, right? Yeah, the denominator is 2 and this factor. Or K, you're using K again, same thing. -1 to what power? +1. This one. Yes. Yes, go ahead to TSA. This is the last thing. Give 10-9 a try. And then one last thing here, you would have your x minus pi over 2. The end. 2n plus 1. So the big idea that I want to stress is that you can have the function representation. You can have the expanded representation, and you can also have the series representation, and they mean the same thing. So according to that red chart, they either converge and it works everywhere, or maybe it only works between -1 and +1. Okay.
So, I should try to stop by and grab the test tomorrow, if it's a take-home test. So we can get here on.
Agreed. So you'd really like a paper version of the take-home test tomorrow?
Oh.
No. I'm not gonna be here tomorrow, that's the work. So, how do we feel about an online take-home test? Printable if we want it to be, but
How would that, like how would you type that?
Write it in.
yeah, you can put it in a notebook and submit a
Oh.
picture of your work. Yeah, no, don't type math. Typing math is.
I was thinking Google form, but I was.
No, that's my biggest concern with any of that electronic stuff. I will have paper copies for people who want them, but if we don't meet up with each other, then I will still make it so it's doable for you as well. All right, do we have, do you guys have notability on your assets or markup or something?
Yeah.
Okay, all right,
Giving us
Chat,
five.
thank you. Yeah, I'm gonna give it to you on Friday, but they're leaving